Events A and B are independent. Find the missing probability. I want to remind you that sometimes the probability of A and B is written using an upside down U. Now, in order to find the missing probability, I'm going to use the independence formula since I'm already under the assumption that both of the events are independent. I'm going to plug in what I know and then I'm going to solve for the missing piece. In this case, that's going to be the probability of B. So the probability of A is 9 over 13. The probability of B is what I'm trying to find. So to make it a little bit more pleasant, I'm going to call it X. And the probability of A and B is 63 over 104. In order to solve for X, I have to solve this equation. And now the goal here is to isolate X, so I'm going to pay attention to the fraction that's next to it. In order to eliminate this fraction, I can multiply both sides by the reciprocal, and the reciprocal is just the flipped version of this fraction. So here, if I flip 9 over 13, I'm going to get 13 over 9. Whatever I do to one side, I have to do it to the other. So on the right hand side, I'm also multiplying 13 over 9. Now on the left hand side, I see a 13 on the top, I see a 13 on the bottom. That means that I can cancel them out, and the same thing goes for the 9s. So now I succeed in isolating X. The only thing I have to do is to simplify the right hand side. Now here I notice that I have a fraction with very large numbers. So before I begin to multiply things together, I'm going to see if they are multiples of each other. For example, I notice that 9 is a multiple of 63 since I can rewrite the 63 as 9 times 7. And then 13 is a multiple of 104 since I can rewrite the 104 as an 8 times 13. And now I'm going to multiply the 13 and the 9, and I'm going to cancel out the quantities I see top and bottom. I see a 13 on the top, 13 on the bottom. Those are going to cancel out. The same thing goes for the 9s. So I get that X is equal to whatever is remaining here. That's going to be the 7 over 8. Recall that X, I said that that was going to be the probability of B. So the probability of B is 7 over 8. Let's move on to another example. Here I have that both events are independent and I have to find the missing probability. This time I'm trying to find the probability of A and B. Now my goal is to eventually use the independence formula. However, this requires us to know the probability of A. Right now I have the probability of not A. So in order to get the probability of A, I'm first going to have to apply the complement rule. So here I have the probability of A plus the probability of not A. In this case, that's going to be 4 over 5. That's going to equal 1. Now I have to solve this equation and I have to isolate the probability of A. I can do that if I subtract 4 over 5 on both sides. And I get that the probability of A is going to equal 1 minus 4 over 5. Because I'm subtracting a fraction, I'm going to need to get the common denominator. So I need to get a common denominator of 5. So the 1, I can rewrite it as 5 over 5. And now I can subtract the numerators. 5 minus 4 is going to be 1. And I keep the common denominator of 5. So the probability of A is 1 over 5. And now that I have the probability of A, I can apply this formula and substitute the probability of A for 1 over 5. I'm going to multiply that with the probability of B. That's going to be 2 over 5. And when I multiply those two quantities together, that's going to give me the probability of A and B. Here, 1 times 2, that's going to give me 8, 2. And 5 times 5 is going to give me 825. So the probability of A and B is going to be 2 over 25.